Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in exercise 12.1 fourth sum. So we need to solve the given linear programming problem graphically. And what is the given question here? Minimize z equal to 3x plus 5y and subject to constraints are four inequalities we have. Okay, so what we are going to do is using the inequalities, first we are going to find out the feasible region. Okay, what is meaning of the feasible region? For all the four inequalities, if the common solution space exists or not, we are going to check. If it is exist, then we will say z has the feasible region. Okay, in case if there is no common solution space, then it is not feasible, solution does not exist for that particular sum. Okay, so now what we are going to do is the given for the given inequality we are going to find out the solutions, okay, in a graph. And you can notice that last two inequalities, that is x comma y greater than or equal to 0, no. So what is that? X comma, that is x is greater than 0, greater than or equal to 0, and y also greater than or equal to 0. So always remember one thing, all linear programming problem lies only in the first quadrant. Okay, so by default you will have these two conditions for all the questions. Okay, so in four quadrants, this particular line, okay, so this particular line, that is x-axis, is the y equal to 0 line, and y-axis is the x equal to 0 line. Okay, and what it says, x greater than or equal to 0, meaning is what? X should be equal to 0 or more than 0. So that means right side to the graph we will have that. Okay, so x greater than or equal to 0 meaning is what? This is the solution space for the x greater than or equal to 0. That means first quadrant and fourth quadrant the solution lies for the x greater than or equal to 0. And now y greater than or equal to 0. No, what is it? Y greater than or equal to 0? Y equal to 0 line we have. Okay, so we have above the y axis and below the y axis. Y greater than or equal to 0 meaning is what? Above the x axis. So we will have solution space for y greater than or equal to 0, first quadrant and second quadrant. So in common, okay, so since the both the inequalities given, no, so in common which quadrant we will take? Only the first quadrant. Okay, so if you see this condition, x comma y greater than or equal to 0, understand that our solution space only we have in the first quadrant. Okay, now in a first quadrant, the other two given inequalities, no, in the first quadrant, these two where the solution space it shares, we need to check common solution space. Okay, for that what we are going to do is the given inequalities we are going to change it as a equation. So let x plus 3y equal to 3. Okay, to draw the line of x plus 3y equal to 3, minimum 2 points are required for us. So if x equal to 0, hmm, if x equal to 0, then 3y equal to 3 we will get 0 plus 3y. So which is 3y equal to 3. Then 3 1 times 1 time, then y equal to 1. If x takes a 0, what is the corresponding value of the y? That is 1. Okay. Now if y equal to 0, if y takes a 0, then corresponding x value will be 3. Okay. So these 2 points are enough to draw the line of x plus 3y equal to 3 in the graph. Okay. So let's plot it. So as I told you that our solution space only we are going to have in first quadrant. So I am going to give more space for the first quadrant. If you're drawing in an actual graph, no, we can able to get the perfect one. Okay, here I am just doing it in a roughly, but I'll try to do it in an accurate way. So giving equal spaces. Okay, till this it's enough. Now in y axis, Okay, I guess it's enough. Now, what is the first point? We have 0, comma 1. This is the first coordinate point. If x is 0, it lies in the y-axis. No. So, 0, comma 1. Which point? They're talking about this one. This point is 0, comma 1 point. Okay. And what about the other one? 3, comma 0. So, where do we have 3, comma 0? If y is 0, it lies on x-axis. So, this particular point is 3, comma 0. Okay. Now, let's join both the points. So this line is x plus 3y equal to 3 line. Okay, x plus 3y equal to 3 line. Okay, after drawing this line, you can see the graph is dividing into two portions. One is above this one and one is the below this one. So we need to identify for the given inequality where the suitable solution space lies, whether this side or this side of the graph. We need to identify that. Okay, for identification, what we can do is randomly take any point from this side. Okay, any point. So 3 comma 1, shall we check? 3 comma 1, this side means 0 comma 0. So 0 comma 0 or 1 comma minus 1, you can take any point. Okay, so 0 comma 0, if you take it, whether is that condition satisfies. If x is 0, y is 0, if you substitute in the first inequality, 0 plus 3 times of 0, which is 0, is that 0 is greater than or equal to 3? Is it true? Which fails the condition. So that means we can understand the solution space, we don't have this side. Okay, we don't have this side for the given inequality. Then obviously the other side only will have a solution. So for the confirmation, we can take 3 comma 1, any one point, just take it and substitute over there. 3 comma 1, shall we take it? 3 comma 1, substitute in place of x as a 3, in place of y as a 1, then 3 plus 3, which gives you 6. Yeah, 6 is what? Greater than or equal to 3. So where condition satisfying. So we identified the solution space for the given first inequality. We have this side to the graph. Okay, now for the second inequality. Okay, same way, to identify the solution for this particular inequality, we need to draw the line of the x plus y. So for that, I'm going to consider the given inequality as a equation, x plus y equal to 2. Okay, now to draw the line of x plus y equal to 2, minimum 2 points are required for us. So I'll take x as a 0, 1 point, y as a 0, then corresponding values I'm going to find out. If x takes the 0, if x takes the 0, y value will be 2. If y equal to 0, x value will be 2. So the coordinate points are 0 comma 2 and 2 comma 0. So we will have it here. So 0 comma 2 this point, 2 comma 0 this point. I'll just write it here itself. This point is 0 comma 2 and this point is 2 comma 0. Now on connecting these two points, yeah, we got a line of x plus y equal to 2. This red line is what? X plus y equal to 2 line. Okay, now this forget about the previous line, that is x plus 3y equal to 3 line. After drawing this red line, that is x plus y equal to 2 line, you can see the graph is dividing into two portions. One is above, the other one is below. Okay, so we need to identify the solution for the x plus y greater than or equal to 2. So randomly take any point this side. Okay, so shall we take 2 comma 2, which lies this side of the red line? Okay, 2 comma 2, any point you can take. 4 comma 10 you can take, 100 comma 100, but when we take the values in a smaller way, it's easy to calculate. So for calculation purpose, let's take a smaller values. So I'm going to take 2 comma 2, shall we will take. Okay, so 2 comma 2, if we substitute in place of x as a 2, y as a 2, answer is 4. That means condition is satisfying. Yeah, result, whatever result we got, it is the greater than or equal to 2 only, no? So the condition satisfying, that means you take any point from that side, always the condition satisfies. That means the points, whichever point lies this side, is a solution for the second inequality. You can see the yellow line and red line is overlapping. So wherever it's overlap in the first quadrant, okay, do remember, wherever it overlaps in the first quadrant, that will be the solution space. Okay, since the common solution is there. Okay, now I'll talk about the other two inequalities. So what is the other two? The complete first quadrant. So this gives the first quadrant. So in a first quadrant, okay, in a first quadrant, you can notice that I'll start drawing from here. I'll just highlight the common solution space alone. There's a line. I'm just highlighting it. So here, then this portion, if you notice, from here to here. Okay, again, here to, sorry, only in the first quadrant. No, it goes on. And same way here, only in the first quadrant, this way. Okay, so basically, I'll just shade it in a white. From this will be the, it goes on actually. Just for the identification, I'm just drawing it again. So from here. So the white shaded portion, no, that is the common solution space for all the four inequalities. Okay, so that white shaded portion is the common solution space for the all the four inequalities. Okay, but you can see that, is it a closed figure? No, it's a open, right? So it is unbounded. Okay, it is unbounded. Feasible region is exist, but only case is it's unbounded. Whether it's a bounded or unbounded, we have to take the corner points. If it is bounded, it's easy to identify the corner point. So in this case, wherever the four inequalities, we have drawn the lines, no, of it. Okay, what are the lines we have? X plus 3y equal to 3 line, x plus y equal to 2, and x equal to 0. I mean, x comma y greater than or equal to 0 means x equal to 0 line, y equal to 0 line. Wherever these four lines meets each other in the common solution space, that will be the corner points. I'll just highlight it. So you can notice that this will be um, here. That means x axis. No, there is no point meeting here. This point we can take. I'm just highlighting it. So 0 comma 2 one corner point. Okay, where that x equal to 0 and this red line is meeting. So this is one corner point, and you can notice that the red line, yellow line both are meeting it here. No, then this will be the another corner point, and you can notice here the yellow line is meeting the x-axis. So this will be the one more corner point. Yeah. So that means only we have three corner points here. This corner point is what? 3 comma 0. This one is 0 comma 2. This corner point we don't know, but it lies between 1 and 2, right? Here, and it is less than 1 the on y axis, if you notice. So what we can do is, to get the accurate point, we can solve these two lines. Okay, that equations, if we solve, we can able to get the exact point. Okay, so using the elimination method, quickly let's solve it. So x plus y equal to 2, then x plus 3y equal to 3. Changing the sign, x gets cancelled. Then we have minus 2y, and here what we are getting? Minus 1. Minus cancel, y equal to 1 by 2. Okay, if y equal to 1 by 2, substituting in this equation, no, x plus 1 by 2 equal to 2. X equal to 2 minus 1 by 2. Then x equal to 4 minus, taking the LCM. Okay, 4 minus 1 by 2. Then x equal to 3 by 2. So what is the coordinate of this point? This coordinate point is, I'll write it here, 3 by 2 comma 1 by 2. Okay. Now we got the corner points as well. So just understand, for all the 4 inequalities, we found the common solution space. That means the feasible region exists. Okay, feasible region exists means we can say solution also exists. Okay, but you can notice that it is not a closed figure. It is open, so it is unbounded. Okay, so it can be seen that feasible region exists. Then exist. Linear programming problem or LPP, both are same. Okay, for the given LPP, okay, and it is unbounded, and it is unbounded. Corner points are, if you want we can name it. Okay, corner points are 0 comma 2. Okay, 0 comma 2. The other corner point 3 by 2 comma 1 by 2, and other one 3 comma 0. Okay, totally we got the 3 corner points. Now these corner points we are going to substitute in the given Z. Corner points and given Z, 3x plus 5y. 3x plus 5y. First corner point 0 comma 2, 3 by 2 comma 1 by 2. The other one 3 comma 0. Now one by one let's substitute in the Z. Okay, if x takes a 0, it's completely the first term is going to be 0. 5 2s are 10. So you will be getting the result as a 10. Next 3 by 2 comma 1 by 2, if you substitute here 3 comma 3 by 2, in place of x I am replacing it as a 3. Okay, now in place of y as a 1 by 2, what is the result? 9 by 2 plus 5 by 2, which is 14 by 2. We are getting it as a 7. Okay, next 3 comma 0, if you replace 3 3s are 9 plus 5 times of 0, which is 0, then 9 only the result. Okay, so we got the corner points as 10 7 9. And what they're asking actually, minimize the Z. So what is the minimum value that we got out of these 3 results? What is the least value in this 7? So that means this is the minimum. But since it's a unbounded, if it is a bounded, no, that's all the result. 7 is the minimum. Z is getting the minimum at 7. I mean minimum value is 7 at 3 by 2 comma 1 by 2. That's all we can end the solution. But since it's a unbounded, the 7 is may or may not be the minimum. You got it? Since the feasible region is unbounded, I'll write the same. Okay, since common solution space. Okay, feasible region is unbounded, 7 may or may not be the minimum. We're not sure. It's a 50-50 chances now, possibilities. To confirm it, what we have to do is, we need to draw the graph of the inequality. What is the minimum value? 7, no. The given Z, minimum means less than symbol you have to use. Okay. So, you need to draw the graph of inequality. So, let's draw the graph of, understand, Z equal to what? What is the given? 3x plus 5y, no? Write that. 3x plus 5y. And in a question, what they're asking here? Minimize only, they said. So we found the minimum value, right? Minimum means less than symbol. In case same unbounded but maximize, when we are finding maximum value, then 3x plus 5y greater than 10. You understand? Minimize, they said minimum value only we are writing. So you have to use a less than symbol. 7. We need to draw the graph of 3x plus 5y less than 7. To draw the graph of the inequality, generally what we do, we'll convert it as a equation, no? So same. Let's convert it as a equation. So let 3x plus 5y equal to 7. So to draw the line of 3x plus 5y equal to 7, we need minimum 2 points, no? 2 points are required for us. If x equal to 0, then corresponding y value will be 5y equal to 7. Y equal to 7 by 5 we are getting. Okay, approximately it is like 1.4 we are getting. So I'll write it 1.4 itself here. Okay. Now if y equal to 0, if y equal to 0, then 3x equal to 7 we will get. Then x equal to 7 by 3. Then approximate value of the 7 by 3 is around 2.333, like that we are getting. Okay. So 2.3. Let's take it like this way. Okay. Now in the same graph, you have to plot these two values 0, 1.4, 0, 1.4. If x is 0, it lies in the y-axis. 0, 1.4 somewhere here. This point is 0, I'll just highlight this one. This point is 0, 1.4. Okay. And the other point is what? 2.3, 0. 2.3, 0. Where do we have? Here. Somewhere here. Here you will get it. Now let's draw the line. And connecting these two. Yes. We draw the line of what line? This one? 3x plus 5y equal to 7 line. 3x plus 5y equal to 7 line. But we need to identify the solution space for this 3x plus 5y less than 7. Okay, now randomly take any value. This side let's check first. Okay, let's take it for 0, 0. Okay, so if we substitute 0 in place of x as a 0 and y as 0, then 0 plus 0, which is 0, 0 less than 7. Is this true? Yes. So that means the solution space for 3x plus 5y less than 7, where it lies? It lies this side to the graph. Okay, it lies this side to this graph. Now you can notice one thing. For the feasible region and for the graph of 3x plus 5y less than 7, do you see any common solution in this? No, it's not overlapping. You can notice that it's not overlapping at all. The white shaded portion only the feasible region. The green shaded, the green lines, no, the green shaded part is the graph of x plus 3y. Sorry, it's a graph of 3x plus 5y less than 7. Okay, do you see any one point also not matching, right? There is no common space. It's sharing for, if you notice, for the feasible region and for the graph of 3x plus 5y less than 7. Less than 7 means what? Only the shaded one. That line also, that 3x plus 5y equal to 7, that line also is not a solution. This side to the line only the solution space starts. Okay, so that means a feasible region and the solution of 3x plus 5y less than 7 is not sharing the any solution at all. So now we can finalize 7 is the minimum. You understand? So after drawing the graph of 3x plus 5y less than 7, you can notice that the feasible region and the solution space of this one has no common point. Okay, there is no common point. So we can say that 7 is the minimum. We can confirm now. Okay, so it can be observed from the graph. From the graph, what we observed there, the feasible region has no common point. No common point with 3x plus 5y less than 7. So, if it is no common point, then we can 100% confirm 7 is the minimum. So, 7 is the minimum value. Okay, minimum value of z. At what point we got this? 3 by 2 comma 1 by 2. Okay, so that's all the solution for this. Thank you for watching and please do subscribe. Thank you so much.